like, I'm just going to pick some problems from this. I'll start off with a basic one. I'm going to start off with dy dx equals x over 3. Okay? Now, in order to get to the anti-differentiation aspect of this, we're going to pull and separate our variables. So we end up with the dy equals to 1/3 of x dx. Are we okay with this? All right. Now, at this point right here, I'm wanting to find the equation that yields this. So, typically we have our equations, especially if it's a function, in the terms of y equals something. So to get to that form here, I'm actually going to anti-differentiate both sides. Now, the antiderivative of dy would be y plus some constant. And what would be the antiderivative of 1/3 of x?
It's n plus 1, so it's 4. So 1 over 4/3 x, 4/3.
Not 4. Remember this. What's n here? It's 1, right? So n plus 1 would be 2. So it's x squared over 2. Again, n is 1. N plus 1. Okay, you're good now? All right.
Yeah.
And then plus c, right? All right. Now, all right. Okay, so I've got this y plus c and this x squared, but I want it in terms of y, right? So I need to move this c over to here, right? So what happens with it? No, it doesn't. A constant minus a constant is still a constant. So we get that y equals to x squared over 6 plus a constant. And this is going to happen in all of these problems in AP Calculus. So we actually don't, from here on out, we're not going to show this y plus c. We're just going to let this c be represented on the left-hand side, okay? So that's the last time you'll see me do that. So let's look at another example here. I'm going to do one with an initial condition in it. So, heck, let's do a u substitution as well. So dy dx, and not all of them will start off as dy dx. Sometimes it'll be dy equals something dx. But we're going to have x times the square root of x squared plus 1. And we're going to say that y of 0 is 1. Are we good to keep going? All right, so before we can integrate, let's separate our variables. So the antiderivative of dy is going to equal to the antiderivative of x times x squared plus 1, square root of it, that is, dx. We had to pull our dx over to that side. And again, you're going to ask, where does the dx go? Well, remember, the dx is just saying that this was the variable that we were taking the derivative with respect to. So once we take the antiderivative of it, we don't need it anymore. So the antiderivative of dy, again, is just y because we're going to put our plus c on this side. Now, x times the square root of x squared plus 1. We need a u substitution here. So what do y'all want to let u equal to? Whatever y'all choose, I'm going to do, and we'll see if it's right or not.
Square root of x squared plus 1.
The square root of x squared plus 1, okay. So let's let u equal to x squared plus 1 to the 1/2 power. Okay? All right, so, y'all don't write this down, it's wrong, but I want you to see what happens when it's wrong. So we get du equals to 1/2 of x squared plus 1 to the negative 1/2 power, then times 2x, right? And dx. All right, so here my 2's would go and play with the dodo birds. So we would get du is equal to x over the square root of x squared plus 1, right? Because that's what that 1/2 negative means, right? Times dx. So this is already u right here, correct? And the x dx is fine, but we end up with this extra value of the square root of x squared plus 1 in it. So that's where I see, oh, I picked the wrong thing. So let's try something different. Now I'm going to pick the right thing right now. So I'm just going to let u equal to x squared plus 1. So du is going to equal to 2x dx, right? Got a hair there. So du over 2 is going to equal to x dx. All right, so I've got my x dx here, which is going to become du over 2, and then this is u to the 1/2 power. And now everything's taken care of. But again, it's okay to pick the wrong thing.
How did you say you said how you,
Knew it was wrong?
yeah.
Because I ended up with a value of this something over the square root of x squared plus 1. And see, I don't have that in a denominator anywhere for it to be able to cancel out. Now, if it was just a constant, if this had been like 1/2 or x over 2 even, I could pull that 2 out front by multiplying. But I can't pull out a variable. I can't pull a variable in front of my integral symbol doing u substitution. So are we okay to keep going? There is something called integration by parts where you do a little bit of that in it, but for now, so this is it. And here's a hint for you. Typically when we do the u substitution stuff, you're typically, now I'm not going to say you always won't, because I'm sure there's a time when you would, but you're typically not going to have it to the exponent in the front. If it's something you can already take the derivative of, you're typically not going to. Again, you could, it's possible, but it's typically not going to happen. So that's again just a hint for a starting point. All right, so y equals to 1/2 of, okay, so integral of u to the 1/2 would be 2/3 u to the 3/2, right? Plus a constant, right? Okay, now I'm going to go back and plug in what u is. That just sounds like bad grammar. All right, 1/2 times 2/3 is 1/3. And this becomes x squared plus 1 to the 3/2 power. And then what's 1/2 times c? Still just c, right? Because a half a constant's a constant. And that is my solution. At first, I'm not done yet. Let me know when I can keep going. I've done the anti-differentiation, right? But I was told here I have this as my initial condition, that y of 0 is equal to 1. So I'm going to say that Again, what am I doing when I do an initial condition? I'm trying to figure out what the specific C value is for this specific problem. So 1 equals to 1/3 of 0 plus 1 would be 1. So 1 to the 3/2 power plus C. Are we still good? So 1 equals 1/3 plus C. So C is going to equal to 2/3. So my final answer here is, for this equation, y equals 1/3 of x squared plus 1 plus 2/3. Y'all look at that for just a second. Take it in.
So how did the x squared plus 1 become 1 and the y became 1?
Because you plug in x is 0 over here, which will simplify out to 1, so that'd just be 0 plus 1. Y becomes 1. because that's what-
Well, what's 1 to the 3/2 power?
I meant like on the,
Why are we
Oh,
solving for y?
thank you.
Because that's.
That is to the 3/2 power. Thank you. Did y'all catch that?
I did, but I had
Okay.
a question.
What's wrong?
I had a question.
Okay. It should be to the 3/2 power. Thanks for catching that. All right. Well, let's keep on rolling. Can I erase this? All right, we're gonna do another differential equation where we plug in with a specific value. Now this one's gonna become a little bit more involved. So we're going to have dy equals 2xy squared dx. Now, this problem right here, if I end up with the graph of the original equation, it's not gonna be a function. Okay? So just know that going into it. I need to separate my variables out. By the way, there is always on the AP test a differential equation problem. And always on that differential equation problem, you're gonna get 1 point just by separating the variables. So, dy over y squared equals 2x dx. That just earned me a point out of 1 point out of 9 points on that free response question. Now, again, what's the next step I do here? Say that again? I do the antiderivative of both sides. So I'm going to rewrite this as y to the negative second dy equals the antiderivative of 2x dx. I think y'all are probably seeing now why this problem is a little bit more involved than the last problems. The other problems we've done have been us just taking the antiderivative of dy and saying it was y. But what's the antiderivative of y to the negative second?
Y to the
Negative 1 over y. And this would be 2x squared over 2, right? Which would just be x squared and then plus our constant. Oh, I never gave us the initial condition. The initial condition for this problem is that y of 0 equals 1/2. Now, here's the really good news. On the AP test, when you get to this step right here, you know we said we earned 1 point for doing this, right? All right, if there's anti-differentiation with respect to the y, this step is usually worth 2 points. Every once in a while it'll just be worth 1 point, but this step is usually gonna be worth 2 points. So you get a 1 point for doing this and a 1 point for doing that. Now, I need to solve for y, right? Well, I need to take the reciprocal of both sides here. So y is gonna equal to 1 over x squared plus c. And it's gonna be the negative of that, just to get it positive. I mean, just to get the y value as being positive. And that is the general equation. All right, so like I said, we've earned, up to this point right now, we've earned 3 points. There are 2 more points to earn. So the next point we're gonna get is by setting 0 here and 1/2 here. So we get that 1/2 is equal to -1 over c. Again, plugging in 0 for x. So c is equal to what?
-2.
-2. So that's gonna be my 4th point. My 5th point is y equals -1 over x squared minus 2. And that's where I earn my 5th point, by writing the specific equation out. So that's 5 out of 9 points. There'll probably be some question about the slope at a particular value, or this may have started off as being a slope-filled problem and you had to go from there, or whatever. So, that is the solution. Any question about that? Okay.